Hi class, and welcome to another video lesson. We're on section 5-5, day 2. This is the second day of working with 5-5. We're still simplifying radicals. Yesterday's video lesson simplified radicals that all involve numbers. It talked about like the square root of 50, something like that. Now we're going to talk about simplifying radicals when there's letters involved, or a variable, such as the square root of x to the 7th, for example. Okay, so now, just so we're all speaking the same language, whenever we say it's the square root, we assume that there's a 2 right here. It's the second root of x to the 7th. So this 2, this is called our index. This sign right here is called the radical sign. And then this number right here is called the exponent, that number 7. So just so we have those three terms down, so if I ever use them in this video lesson, you'll know what I'm talking about. The index is the number on the radical. The exponent is what the base is raised to. It could be x to the 9th, could be x to the 15th, whatever the case might be. And then we have our radical sign. The index, we're always going to be talking about the square root today, but it could be anything. It could be the 3rd root, it could be the 5th root. Any number could be our index. So just so you know that as well. So as we look at this one, we're going to simplify the square root of x to the 12th. You see this rule up here? I'm not going to focus on this very much. To be mathematically correct, if you have an even index, which we do, this is always the square root, and 2 is even, and we have a result of an odd exponent, you need to have an absolute value sign. If you're curious why that rule is, I can explain to you that in class. But I'm not going to address that in this video because I'm not going to require you to know that for our next chapter test. So don't worry about knowing it. If you're curious and you want to, be sure to ask me in class. Alright, so here's what our strategy is going to be for solving all of these, class. We're going to take our exponent and divide it by our index. So it's going to be 12 halves. What number is that? Obviously 12 halves reduces to 6. So what we're going to take out, class, is we're going to take out an x to the 6th. And there's our answer. Our answer is x to the 6th. This one is the most basic example. It's going to get obviously more complex, but our rule of thumb here is we're going to take our exponent and divide it by our index. Now let's just take a moment to see if this makes sense to you. If the square root of 49 is 7, okay, if we say 7 times 7, that equals 49. So 7 squared is 49, and the square root of 49 is 7. We could say the exact same thing with this x to the 6th right here. Okay? If I say x to the 6th times x to the 6th, that equals x raised to the 12th. So that means the square root of x raised to the 12th is x to the 6th. And that's exactly what we see right here. So you can kind of maybe take a step back after you get your answer and just square it and see if you get right back to the number underneath the radical again. If I square x to the 6th, I get right back to x to the 12th. So our answer, x to the 6th. Looking at problem number 2, the square root of 36, x to the 10th. Well, we have a coefficient, so we're actually going to take the square root of that. We're not going to do this whole dividing by 2 thing. We're actually going to take the square root of 36. What's the square root of 36? It is 6. And then we're going to take our exponent divided by our index. We get 10 halves as being 5. So I can take out an x to the 5th. And there's my answer. My answer is 6x to the 5th. And again, if you think about squaring this, what's 6x to the 5th times 6x to the 5th? It's 36x to the 10th. So the square root of 36x to the 10th, there's our answer, 6x to the 5th. Number 3, I'm going to take the square root of 4 and get 2. And I'm going to take 14 halves, because it's the exponent divided by my index, and I get a 7. So I can take out an x to the 7th. So I'm always dividing that exponent by 2. Our answer for this one is 2x to the 7th. Number 4. Now we can't take out 50. There's no such thing as taking the square root of 50, but we can reduce 50. 50 is the same thing as 25 times 2, x to the 4th. So now I can take out the 25, and out comes 5. I can take out x to the 4th, because I'm going to take 4 and divide it by my index of 2. So 4 halves is the same thing as 2, so I can take out an x squared. So 5x squared, so I took out this, and this 2 is left underneath the radical. So I still have the square root of 2. 5x squared square root 2. That is my answer for problem number 4. Moving right along, we continue. Why don't you guys pause the video and try number 5 on your own. After you pause the video, hopefully you got this. 9 multiplied by 3, x to the 12th, y to the 6th. I can take out this 9. The square root of 9 is 3. I can take out this x to the 12th because 12 halves is the same thing as 6. So I have x to the 6th on the outside of the radical. I can take out this y to the 6th because 6 divided by 2 is 3. So I could take out now a y cubed. So this number out here always represents the exponent that comes outside the radical. X to the 6th, y to the 3rd. So I took out this, I took out this, I took out this. What's left? The square root of 3. There's our answer for problem number 5. Problem number 6, we talk about a whole new animal now. Okay, so pay very close attention to this one. We now have an x raised to the 5th power, which doesn't come out nice and clean when we divide by 2. So here's what we're going to do. We could still take the square root of 36, that part's easy, and we get 6. So a 6 comes outside the radical. Square root of 36 is 6. We're still going to take our exponent and divide by 2, so that always stays the same. So 5 halves. As a mixed number, that turns into 2 and 1/2. So I could still take out this number. I could take out x squared. So this x to the 5th, I can take out an x squared. But now I still have this. And this is still left underneath the radical. So this still represents our index. We're still going to have the square root of x to the 1st. This is my exponent. So I took out an x squared term right here, but I still have one more x underneath the radical, and that's x to the 1st. So this is my answer for this one. And Excel math will never have this index written there because we always assume that the index is 2. So my answer is 6x squared times the square root of x. And again, Excel math won't have this 1 there because it's always understood that that exponent is 1. So 6x squared square root x. That's my answer for problem number 6. That might be a little difficult. I think it'll get easier and easier the more we work with it. So let's try problem number 7. 49 comes outside the radical as a 7. The square root of 49 is 7. The z cubed, we would take 3 and divide it by 2. So we would get 1 and 1/2 as a mixed number. So I can take out a z to the 1st. So I take out a z outside the radical, and I'm still left with 1/2, which means it's the square root of z to the 1st. The 1st is my exponent, so it's the square root of z to the 1st. There's my answer for problem number 7. 7z square root z. Number 8. Now once again, we're getting into something different because now we're adding radicals. So just like yesterday's lesson, the only way you could add a radical is if the radicals are exactly the same. Square root 12x and square root 27x are not the exact same thing. But just like yesterday, let's see if we can break it down first. So this 12 breaks up into 4 times 3 with the x there, plus 13 times 27 is 9 times 3. Now let's see what happens when we take things out. I could take out the square root of 4 as a 2, and now 9 times 2 becomes an 18. So I have 18 square root 3x plus this 9 I could take out. The square root of 9 is 3. 13 times 3 is 39 square root 3x. Whew! So I have 18 square root 3x plus 39 square root 3x. My radicals are identical. Square root 3x, square root 3x. That means I could add 18 plus 39. I add 18 plus 39, and I get 57 square root 3x. I can't take out the square root of 3. I can't take out the square root of x. So I am left with the square root of 57 square root 3x. There's my answer for problem number 8. Moving on, problem number 9. We're going to try to break down these radicals. Why don't you guys pause the video and try this one on your own. It's very similar to problem number 8. After you've tried this one on your own, you got a negative 2 square root 9 times 5y plus 4 times square root 5 times 4y. You took out the 9 as a 3 and got a negative 6 square root 5y. Plus, you took out the square root of 4 as a 2 and multiplied by the coefficient of 4, so 4 times 2 is 8 square root 5y. Alright, and then you saw you had square root 5y and square root 5y, so you added your coefficients. A negative 6 plus an 8 is a positive 2 square root 5y. There's our answer for problem number 9. Problem number 10. I have a 48 underneath this radical, so I want to break that down. I'm subtracting a radical of 27x to the 8th, so right now I can't combine like terms, but I try to get my radicals the same. So I still have 3x to the 5th square root of 16 multiplied by 3. That's the same thing as 48. Minus 2 times the square root of 9 times 3, x to the 4th. Ah, stupid. X to the 8th. Sorry about that, class. X to the 8th. Okay, let's simplify these now. I could take out the square root of 16 as a 4, and 3 times 4 is 12x to the 5th square root 3. I can take out a 9 as a 3, so I get a minus 6. I can take out an x to the 8th. 8 divided by the index of 2 is 4. So I could take out an x to the 4th. So I have x to the 4th. There's no remainder, so this 8 is gone now. The x to the 8th is gone. And so all that's left inside is the square root of 3. Okay, this is where it becomes a little bit tricky, because you want to combine like terms, because you have the cubed root of 3, the square root of 3 and the square root of 3. However, you can only combine x to the 5th square root 3's with other x to the 5th square root 3's. And you can only combine x to the 4th square root 3's with other x to the 4th square root 3's. So in this way, we are done because we can't combine like terms. The radical and the variables have to be identical for us to combine like terms. And they are not, so this is as simplified as we can make it. It's kind of an ugly looking answer, but this is as simplified as we get. Alright, as we move on to numbers 11 through 15, they are a little bit tricky. We got to remember our properties of exponents. When we multiply with variables with common bases, we add their exponents. Same thing with radicals. As long as they're both underneath the radical, we can multiply the bases, and when we multiply with common bases, we add their exponents. So we're going to add 15 plus 7, and we get the square root of y to the 22nd. Again, we get 15 plus 7. As long as they're both underneath the radical, we can do this mathematically. So 15 plus 7 is 22, so we keep y to the 22nd underneath the radical. Now, we can simplify this. We take 22 and divide it by the index. 22 divided by 2 is 11. So I could take out a y to the 11th. So there's my answer, y raised to the 11th power. Moving on to the next one. Again, as long as we're underneath the radical, as long as both of them are underneath the radical, you can multiply the numbers together. So when we multiply 5 times 20, we get 100. When we multiply y to the cubed times y to the 13th, we get y to the 16th. We add, when there's common bases, we add their exponents. So now we have the square root of 10 y to the 16th. So our answer becomes square root of 100 is 10. Square root y to the 16th is y to the 8th, because 16 divided by 2 becomes 8. 10 y to the 8th is our answer for problem number 12. Problem number 13 is going to be those same rules as we had with our properties of exponents. This is the quotient property, so when we have common bases, we subtract their exponents. We assume this is an exponent of 1, so they're both underneath the radical sign. Both of these are, so we can make this as y raised to the 9th underneath the radical. We would take 10 n minus 1 and get the square root of y to the 9th. So now we break this down. We say this is the same thing as 9 halves, and 9 halves is the same thing as 4 and 1 half. So I can take out a y to the 4th. This whole number right here represents how many y's I can take out, and then I have 1 half left over, which means it's the square root of y raised to the 1st. So my answer is left at that. Y to the 4th, square root y. 2 more problems left. Number 14. You guys pause the video and try this one on your own. When you unpause the video, you should have got this. 8 minus 4 is y to the 4th, and it's the square root of y to the 4th. We just subtracted the exponents. 8 minus 4 is 4, and then the square root of y to the 4th is y squared. So hopefully you got y squared as your answer for problem number 14. Last one. We're going to divide the numbers, which means it's going to be 5. When we divide with common bases, we subtract their exponents, so we get x cubed. So it's the square root of 5x to the 3rd. Then we break this down. I can't take out 5, and I can't simplify it in any way. However, I can simplify x cubed. It's 3 divided by the index of 2, so 3 halves is 1 and 1 half. So I can take out an x raised to the 1st power, and then I still have the square root of x underneath my radical. So I took out the x, and I'm left with 5x. There's my answer for problem number 15. Once again, this x to the 1st comes out right here, and then this 1 half, the 2 is still my index. It's the second root of x raised to the 1st power. That's where that 1 goes. So there's my answer, x times the square root of 5x. That was a lot of stuff in one video lesson. Be sure to maybe circle some that you have questions on if you want to ask more questions on them when you get to class tomorrow. We can do more practice problems all together and stuff like that. Be sure to let me know if there's something that you don't quite understand. I'd love to help you out more.